Good morning dear students, I am Vinod Seni, your physics teacher. I welcome you all at your favorite YouTube channel Vigyan Vihan. In our last video, we have discussed about the electromagnetic waves and Maxwell's equations and Maxwell's correction in Ampere's circuit law. Dear students, in that video, we have discussed about electromagnetic induction. The time-varying electric field can generate a magnetic field and time-varying magnetic field can generate an electric field. So dear students, it will be utilized in this video also. I suggest you to please watch that video. Its link is given in the description below and the I button above. You can watch that video. Dear students, in this video, we are going to learn about the generation of electromagnetic waves, its propagation using an antenna, the Hertz experiment. In this video, we will also prove that the electromagnetic waves are transverse in nature. Now dear students, let's start this video. After many experiments, now we know that the light waves, the X-rays, the gamma rays, these all waves are electromagnetic waves. Electromagnetic waves has large range of their wavelength and frequency. Any electromagnetic wave have its speed equal to the speed of light, which is very well known as 3 into 10 to the power 8 meter per second, or you can say 3 lakh kilometer per second. Dear students, in an electromagnetic wave, if the wave is propagating in x direction, then if we consider the electric field is oscillating in vertical plane, or you can say in xy plane, then the magnetic field which is induced due to the time varying electric field will be in perpendicular plane to the plane of electric field, or you can say magnetic field will oscillate in a plane which is perpendicular to the x and y direction. X direction is the direction of propagation, y direction is direction of electric field. Then the magnetic field will be in z direction. So these three properties, the direction of wave propagation, the direction of electric field, the direction of magnetic field will be perpendicular to each other. जब इलेक्ट्रोमैग्नेटिक वेव x डायरेक्शन में प्रोपेगेट होगी तो उसके परपेंडिकुलर प्लेन में मैग्नेटिक फील्ड ऑसिलेट करेगा. मैग्नेटिक फील्ड will be changed in sinusoidal manner. The magnetic field which is varying with time will induce an electric field. Electric field मैग्नेटिक फील्ड के प्लेन के परपेंडिकुलर प्लेन में ऑसिलेट करेगा. इस तरह से वेव प्रोपेगेशन, इलेक्ट्रिक फील्ड और मैग्नेटिक फील्ड एक दूसरे के परपेंडिकुलर डायरेक्शन में होंगे. Dear students, I have drawn a line diagram which is showing first the direction of wave propagation, that is x-axis, the direction of oscillation of electric field, that is xy plane, direction of magnetic field is in xz plane. If I draw these both fields in a same line, then this will be a complicated diagram and it cannot be imagined by you. So I made these two diagrams in different lines. Dear students, in our last video we have discussed about the establishments of Maxwell's equation. Maxwell has given the idea of displacement current and also the conduction current. Both are responsible for the generation of magnetic field. James Clerk Maxwell was the first scientist who have given the idea of electromagnetic waves. according to his consideration, if there is a time varying magnetic field, it can generate an electric field. If there is a time varying electric field, the displacement current is proportional to the time rate of change of electric field, so it will generate an magnetic field. अगर मैग्नेटिक फील्ड में टाइम के साथ वेरिएशन होता है, देन ये एक इलेक्ट्रिक फील्ड जनरेट करेगा. डिस्प्लेसमेंट करंट जो कि इलेक्ट्रिक फील्ड में वेरिएशन की रेट पर डिपेंड करता है, देन इट विल जनरेट एन मैग्नेटिक फील्ड. आफ्टर हिज प्रेडिक्शन on mathematical basis, other scientists made some experiment and they were succeed in their experiments. The success in their experiments is the basis of generation of electromagnetic wave and their propagation in air or in broadcast. Now dear students, we are studying the experiment of Henrich Hertz. In 1865, Maxwell given this prediction. In 1887, Henrich Hertz was the first scientist who succeeded in his experiment for the generation of electromagnetic wave by the means of oscillating electric spark. He could detect this electromagnetic wave by an antenna. Now we are going to study the Hertz experiment by which he could generate the electromagnetic field and also he could detect it by an antenna. Antenna, you can say it is detector. An antenna can work for the broadcast purpose and also it can be used as a detector. Now dear students, we will study how the Hertz experiment's simple setup could prove the existence of electromagnetic waves. These two terminals of a circuit is connected with a time varying electric field. The time varying electric field or time varying voltage, we can get it from an alternate voltage sources or current sources. It is then connected to a coil or induction coil. Induction coil is in form of a spiral or spring. You know it very well. If there is a time varying electric field or time varying current connected to this coil, due to the self-inductance of this coil, a magnetic field will be generated as negative L di upon dt. The self-inductance of a coil depends upon the number of rounds in this induction coil. It also depends upon the length of the coil. It depends upon the number of rounds per unit length of this coil. If there is an induction coil of large L value, L is the self-inductance of this coil, then for a small change in current, there will be large change in the output voltage. So dear students, due to variation in electric field, there will be a large change in corresponding magnetic field. Dear students, if an induction coil of large self-inductance value is connected with the time varying voltage or EMF, then the small change in electric current will result in the large change in output EMF. This EMF is called induced EMF in this coil. Then the output terminals are connected to two different spheres. These spheres are separated by a small gap. The gap between these two spheres was very small and it could not be seen and it could not be observed by an open eyes. These two spheres are then connected to different plates of a capacitor. Now dear students, if there is some potential difference between these two spheres, let the sphere S1 is on positive polarization at an instant and S2 is on negative polarization. These two plates of capacitor will also get charged, and we know that the charge have a tendency to be at the surface of a metal. With the time, there is large value of charge is accumulated on this first plate P1 and same amount of charge will accumulate in the plate P2. Due to the large potential difference between these two plates, a different incident will happen. What is that? The small gap, which is an air gap between these two spheres, will result in a breakdown and a spark will be generated in this space. What is the breakdown? If there is a large value of potential difference, then an insulator can conduct electricity. This is called the breakdown of an dielectric medium. Air is an dielectric medium. Air works like an insulator, and for a large value of potential difference between these two spheres, it will generate an electric spark. By the means of an electric spark, the air could conduct the electricity or electric charge. Dear students, आप इसे फिर से समझ लें. यहाँ पर टाइम वेरिंग वोल्टेज मीन्स अल्टरनेट वोल्टेज सोर्स यहाँ पर लगा हुआ है. यहाँ पर एक इंडक्शन कॉइल लगी हुई है. इंडक्शन कॉइल में टाइम वेरिंग इलेक्ट्रिक फील्ड या टाइम वेरिंग इलेक्ट्रिक करंट जनरेट होने से इंड्यूस्ड ईएमएफ जनरेट होगा. ड्यू टू द लार्ज वैल्यू ऑफ सेल्फ इंडक्टेंस, इलेक्ट्रिक करंट में छोटा सा चेंज होने पर ये मल्टीप्लिकेशन का जो रिजल्ट आएगा, देन इट विल रिजल्ट इन द आउटपुट induced EMF. The output terminals will be then connected to these two spheres. We have studied in the first chapter with the electrostatics. If we place any charge in a metallic sphere, it have tendency to be only at its surface. यहाँ स्फीयर्स पर पोलराइजेशन से जब चार्ज जनरेट होता है तो साथ में जुड़ी हुई ये कैपेसिटर प्लेट्स भी चार्ज होंगी. उससे यहाँ पर हाई पोटेंशियल डिफरेंस जनरेट होने पर इलेक्ट्रिक ब्रेकडाउन होने के कारण इलेक्ट्रिक डिस्चार्ज होगा, जैसा कि क्लाउड्स में देखने को मिलता है थंडर स्टॉर्म के दौरान. देन डियर स्टूडेंट्स, this value of electric field in the gap between these two spheres will be changed with time. The voltage input is varying with time. then output voltage or output current will also change with time. The similar variation could be seen in the electric field between these two spheres. So here electric field is generated. The variation of electric field will generate an magnetic field because according to the theory of displacement current, we know it very well. The time varying electric field will generate an magnetic field. The direction of electric field is in y direction. The time varying electric field in y axis will then generate a magnetic field. The induced magnetic field as it was predicted by Maxwell by the means of the displacement current theory. Dear students, here an electromagnetic wave is generated. This experiment was made with simple equipments in a dark room. The small spark which was made between these two spheres could be seen only in a dark room, but it was amazing that an antenna or a rod which is connected to two spheres having very small gaps, S1 dash, S2 dash, then what Hertz found in the small gap between these two spheres, which is far from this experimental setup, he found here an electric spark without any physical contact. So he found that an electromagnetic wave can travel from one place to another, and an electromagnetic wave can be generated by time varying electromagnetic field or time varying electric and magnetic field. After his succeed, तो हर्ट्ज ने जब ये एक्सपेरिमेंट किया तो इस इनिशियल सेटअप से इलेक्ट्रोमैग्नेटिक फील्ड जनरेट हुआ, और जब इससे दूर रखे एक एंटीना से दो स्फीयर्स कनेक्ट थे और उन दो स्फीयर्स के बीच एक छोटा एयर गैप था और उस एयर गैप में इलेक्ट्रिक स्पार्क ऑब्जर्व हुआ. नाउ ही वाज कंफर्म्ड that an electromagnetic field can be generated by an experimental setup. टाइम के साथ वेरी करने वाले एक इलेक्ट्रिक एंड मैग्नेटिक फील्ड से इलेक्ट्रोमैग्नेटिक वेव जनरेट कर सकते हैं, एक जगह से दूसरी जगह ट्रेवल करते हुए जा सकती है और एक एंटीना से इसे डिटेक्ट भी किया जा सकता है. देन इन द एक्सपेरिमेंट ऑफ हर्ट्ज he found that the wavelength of this wave which was generated was nearly equal to 6 meter. The frequency of such a electromagnetic wave can be calculated by frequency is equal to 1 upon 2 pi square root of LC. इलेक्ट्रोमैग्नेटिक वेव को किस तरह से जनरेट करेंगे? If there is an inductor and capacitor is connected in series, if there is very small resistance of this circuit, then it is connected to time varying voltage, then this circuit can generate a resonance between this capacitor and induction coil. This induction coil can generate a magnetic field. This capacitor can generate an electric field. The value of the electric field in capacitor and magnetic field in the inductor is not constant with time. These are varying with time, and this can generate and time varying electromagnetic field. It will generate and electromagnetic wave. These are perpendicular electric and magnetic fields which can show a wave propagating in x direction. In y direction we considered electric field, in z direction we considered magnetic field. स्टूडेंट्स, एक इंडक्टर एक कैपेसिटर सीरीज में जब जुड़े हों तो रेजोनेंस सर्किट बनाएंगे। जब इस कंप्लीट सर्किट का रेजिस्टेंस बहुत नेग्लिजिबल हो पर एक अल्टरनेटिंग वोल्टेज सोर्स से जोड़ने पर यह सर्किट एक रेजोनेट सर्किट मेक करेगा और इस रेजोनेंस की फ्रीक्वेंसी, एंगुलर फ्रीक्वेंसी can be calculated by omega is equal to 1 upon square root of LC. In the next experiment in 1894 by Jagdish Chandra Bose, he could produce an radio wave of wavelength nearly 5 to 25 mm. Dear friends, Marconi was the scientist who discovered the utilization of an antenna. An antenna is nothing but two separate parts of a metallic rod. Its first part is connected with the time varying electric field. Its second part, the second terminal, is connected to the earth and it will generate an time varying electromagnetic field. This time varying electromagnetic field will then travel from air according to our requirement at another place. We can use a similar antenna to get the signal and it will work like a receiver. This first antenna will work like a transmitter. This electromagnetic wave can travel from air or vacuum. Using the similar antenna at other place, it will work like a receiver, and at receiver we can receive the similar electromagnetic wave. The second part of this terminal is connected to ground. The Marconi was scientists who have given us idea how to transmit, how to propagate electromagnetic waves generated by an experimental setup, and we can transmit this electromagnetic wave using an antenna. This is the complete scenario without which the modern science, the technology could not be established. Now we are using the cellular phones and we can use the cellular phones anywhere in the world. We have already studied can an static charge can generate an electric field. An static electric field, such a charge at rest, result in static electric field. If a charge is moving with constant speed, it can generate an electric field and it can also generate an electric current at constant value. Now dear students, a charge at constant speed, then if it is generating an electric current, then it will result in a constant magnetic field also. Dear students, if a charge is in accelerated motion, then the electric current will be variable with time and the charge will generate an electric field and magnetic field also, and the value of electric and magnetic field will be variable with time. Such a motion of a charge will result into an electromagnetic field or electromagnetic wave. Students, electrostatic charge जो रेस्ट में होगा, it can only produce an electric field. एज वी स्टडीड अर्लियर, चार्ज जब कांस्टेंट स्पीड में होगा, कांस्टेंट स्पीड से चार्ज किसी कंडक्टर में मोशन करेगा तो एक क्रॉस सेक्शन से सेम पार्ट ऑफ टाइम में सेम नंबर ऑफ चार्जेस ट्रेवल करेंगे, देन द करंट, इलेक्ट्रिक करंट dq by dt will have a constant value. A constant value of current will generate magnetic field. The magnetic field B is equal to mu naught I upon 2 pi r. At constant speed से मूविंग चार्ज इलेक्ट्रिक फील्ड जनरेट करेगा और मैग्नेटिक फील्ड की वैल्यू भी टाइम के साथ कांस्टेंट होगी। यहां पर इलेक्ट्रिक करंट भी जनरेट होगा, वो भी कांस्टेंट होगा। लेकिन जब चार्ज एक्सेलरेटेड मोशन में होगा तो सेम पार्ट ऑफ टाइम में एक क्रॉस सेक्शन से क्रॉस होने वाले चार्जेस के नंबर डिफरेंट इंस्टेंसेस पर, टाइम t1 पर, टाइम 2 पर डिफरेंट होंगे। द dq अपॉन dt वैल्यू will be changed if it is accelerated in positive value, if these charges have positive acceleration, then the current value will increase with time. The time rate of change of current will be some positive value. Now dear students, the current is also changing with time here. Then variable electric field is generated, variable magnetic field is also generated. If variable electric field is there, it can generate a magnetic field. Variable magnetic field can generate an electric field. So these two fields can generate each other. These two electric and magnetic fields are perpendicular to each other, and these both fields are perpendicular to the direction of electromagnetic waves propagation. So dear students, we have discussed about the Hertz experiment. We have discussed about the antenna which can be used as transmitter and detector of electromagnetic wave. पानी पिला दे. Dear students, I suggest you all to please pause this video and note down the facts about the generation and production, also about the wave propagation and Hertz experiments. Now dear students, we will discuss about the transverse nature of electromagnetic waves. Here is a simple imagination. Here is a parallelepiped with its edges inclined with x, y and z axis. Its vertices are shown with O, A, B, C, D, K, L, M. If the electromagnetic wave is traveling in x direction, then the electric field will be changed with change in x value. At different points on x-axis, the value of electric field will be different. Now, from the first equation, which is Gauss law for electric field, we can write here E vector dot dA vector is equal to total charge inside the parallelepiped upon the permittivity, but we consider there is no charge inside this parallelepiped, so we can write here 0. the net flux outgoing from this parallelepiped is 0, then we can write it as the sum of flux going out from different faces. Here there are 6 faces of this parallelepiped, so we can write it as O A L K plus, for this lower part, O A L K, A B M L, A B M L, B C D M, O K D C, O A B C. So the total outgoing net flux is 0. We have used the sum of the flux outgoing from each faces of this parallelepiped. Now dear students, only with the change in x value the electric field will be changed, because that is the direction of propagation. x वैल्यू चेंज होने पर ही इलेक्ट्रिक फील्ड की वैल्यू चेंज होगी, y और z वैल्यू चेंज होने पर इलेक्ट्रिक फील्ड में कोई चेंज नहीं होगा. सो डियर स्टूडेंट्स, इफ देयर इज चेंज इन z डायरेक्शन, these two faces KLMD and OABC, there will be same electric field value. So the same value of electric field is incoming from the first surface will outgo from the second surface. So dear students, for these two surfaces KLMD and OABC, the total electric field will cancel out from each other. Similarly, in y direction, if there is change in y value, there will be no change in electric field. Here we are considering only for the electric field for the faces OALK and face BMDC. The value of electric field will be same. The area value is also same for these two faces. So the electric flux incoming from the first surface will outgo from the second surface without any change. So these two parts will also cancel each other. Now only these two parts which are perpendicular to the x direction will remain here. We consider first here the first surface OKDC. At this surface the electric field value is Ex, and at the second surface ABML the electric field value is Ex dash. Now we can write here it as S. The area of the second surface will also be same. We can write here also S. If there is any component of electric field is in x direction, we are considering only that part. In that condition we can write it that Ex dash multiplied with the area S. Also we can write here cos 0, because the direction of x-axis and direction of this area is same for ABML, plus the second part for OKDC. we can write here the electric field value Ex and area value S same here, but cos of 180 degree, or we can write here pi. The total outward flux is equal to 0. Now dear students, after solving it, we can write here the S value is same, S part is common, cos 0 is 1, cos pi is -1, so Ex dash minus Ex is equal to 0. The area value S is not equal to 0, so we can write here that Ex dash is equal to Ex. Now dear students, the result is giving that the electric field value will not change with change in X value. That is an absurd result, because in an electromagnetic wave, if there is energy propagating from one place to another, there must be some change in electric or magnetic field. If the value of electric field is not changing from one place to another, then only one condition is there, that electric field X component is equal to 0. Then we can write it that Ex dash is equal to Ex, and it will be equal to 0. The X component of this electric field is equal to 0. Then we can say the direction of electric field is perpendicular to the x-axis. Then we can say the electric field is oscillating in perpendicular plane to the direction of wave propagation. We can perform the similar derivation for the magnetic field also. In that condition, we will use the Gaussian law for magnetic field, and we will get the similar result. And finally, we can say the electromagnetic wave is transverse in nature. The direction of wave propagation, the direction of magnetic field, the direction of electric field, these three are perpendicular to each other. There is no component of electric field in x direction, so it is perpendicular to the x-axis. Or you can say the electric field is perpendicular to the direction of wave propagation, the wave propagating in x direction. I expect that you have got some new knowledge and it will be very beneficial for you. Please note down some key points for your further reference and practice purpose. Thanks for watching this video till the end. Please like it and share it with your friends. If you are new at this channel, please subscribe this channel and don't forget to tap on bell icon. Also opt for all notifications. Keep learning, keep practicing. Problem solving is always fun. Thank you.